Hi, this is Dennis with A1 Telephone Service and Repair, A1 Electronics. I'll be your host today. This is kind of an ongoing circuit build and design for Jack up in Canada. And we sent him a video of some other footage that we had of the circuit design that we're working on. We're going to get down here to the two new circuits. What you're going to see here is two speakers. They're similar. Two microphones. They are just a little bit different. They have two different manufacturers. And the reason why I want to build the circuit this way is because they are very similar in impedance. And one of the manufacturers will probably be able to be tracked down. Okay, so that's why we're doing that. We have two similar speakers. We have two exact circuits. Now you have to remember something when you're building a circuit. You see these long wires here leading over to this speaker? Well, all that adds resistance into the microphone. Okay, that adds resistance into the microphone, and it also adds resistance into the speaker. So you may have to do a little circuit design and change because of that. Okay, because that can, when you shorten up the wires and change the wires, you got to remember you may have to design the circuit a little different, because it won't be, you won't have the same resistance in the line. This circuit here has a shorter hardwire speaker situation, and that speaker would be a little, the wiring on it would be about that length or a little shorter, and the mic wire would be longer than this. So you have to account for all that. We have a battery cable running over here for a 9-volt battery adapter site type situation, because there's a 9-volt battery plug at the battery case. So what we're going to do is we're going to turn this circuit on and go ahead and let you hear the circuit. Let me plug one of these guys in here for you. And get this plugged in real quick. It's giving me a little bit of a fight here today. Okay. Now, in another video, remember that we talked about having, I'm going to show you a microphone, another microphone element. We talked about how we would get a radio station, pick up a radio station if there was not a capacitor across the mic to cancel out the oscillation. Okay, well, that was in a quick design. So what we did to that capacitor that was on that microphone, we actually added it to the circuit. So that's why you don't hear any music. The speaker that is on right now, out of the two, is this circuit right here, this speaker, and then this will be the microphone. And what we have to do is make sure that we got our one, two, three, four, five, six. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Hello, hello. 1, 2, 3, 4, 5, 6. Hello, hello. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. Okay, what we're going to do now is we're going to unplug this battery from that circuit, and we're going to take over with this other circuit, which is identical basically, except for the voice capsule. And now this speaker is on. One, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Hello, hello. Now, there's two reasons it's going to sound a little different. Number one is it's a different microphone element, okay? And it's hardwired. So that has a little bit to do with some of the resistance. This one over here sounded a little raspy, but it didn't sound like that on the other attempts to fire up the circuit. And I think it's probably got something to do with one of the wires not making a real good contact, but I will check that out after I get done with the video. So basically what we have here is a more refined circuit. Actually, this circuit from the last video has had a resistor added to the mic line because of the shortening of the wires, of the length. See, there's more resistance to this circuit over here because of all the wire, and this is shortened up a little bit here. So we had to. There was a little bit too much of feedback, so we shortened the. Or we had to add a resistance to the mic line, which is not a big deal. I mean, you know, you have to refine the circuit down. So this is a different microphone than this one, but one of the manufacturers should be able to be tracked down. So, and the circuit is designed, I'm going to add in the schematic that I make for the circuit, because we've been drawing up a schematic as we go along and kind of doing the math and figuring everything out. Basically, there'll be a resistor or two that can be changed in value. There may even be a potentiometer take place of one of the resistors so that you can control the feedback. And that may be something at a later date added to the design so that you can build the circuit, preset the feedback situation, and then send it out the door. You know, dab it with a little hot glue and send it out the door. So, you know, that's just a little bit of what's going on at the shop today. This is a view of the back of the two circuits, and like I said, they are identical circuits, and we're just starting to square the circuits away. 1, 2, 3, 4, 5, 6. Hello. So we're coming up on our 10 minutes on this video, and I wanted to show you a little bit what was going on. There's some stuff over there, a lot of parts and things. Like old lady Clinton said, it takes a whole bunch of adults to make a neighborhood. Well, it takes a whole bunch of electronic parts to design a circuit. So I also want to get in here. I don't want to make you dizzy, but I want to swing around here real quickly. This is part of the shop that we're in, and since you don't know who you're dealing with, I want to show you a picture of me that was in the newspaper. So that's actually a picture of me working on something. So goodbye now. We got to shut the video down. Have a nice day. Thank you.